I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have
enough. Hello again, and welcome back to this Philco 60B adventure. First IF transformer right here. We determined in the last video that the primary winding of that transformer is shot somehow. It's open. So I have to take it out. And we start by taking this grid cap off that guy. And then turning the whole thing over and seeing where the IF transformer is. And in fact, it's buried down here. It's under a bunch of stuff. So, got to get the stuff out without losing track of what the stuff is and where it goes. We'll start by making a little bit of room here. These are the what Philco calls the compensating capacitors here. These are how you fine-tune the IF frequency. Pardon me. The one that's in the way is the secondary, the first IF transformer secondary compensating condenser, which is a mouthful. It's right here. So we need to pull this guy. Let me zoom you in a little, or get you in a little bit closer. You can see what I'm doing. Okay, these are held in by a bolt. This guy is. All of them are actually. Held in by a bolt, which I'll remove. There's a nut and a star washer, a square nut and a star washer in my left hand that I don't want to drop. Got him. Then there's the bolt. Then there's a spacer, which I need to grab with something. There's a spacer right here. Put the bolt in the box, and there's the spacer. Okay, and that frees up the compensating condenser. Also frees up the shield that goes underneath it. This guy, so we have those all in our little plastic box now. And now I can see, at least see the first IF can. It's that guy right there with the wooden dowel up the center. I presume that's the former for the transformer. What we want to do is, there are 4 leads coming out of here, corresponding to the leads from the transformer itself, which is right here. One of the leads goes to pin 2 of the 6A7. Another of the leads goes down here to this bank of capacitors right here, and a 33K resistor. Another lead goes down here and back to this. I can't read what that is on this schematic. It's the secondary. Oh, there it is. It's a 2 meg resistor right there. And then the 4th lead goes to the grid cap on the V2 tube, or the 78 tube rather. So we've got 2 grid caps to pull. We've got the 78 tube and the 6A7. That's 2 of them. That should leave 2 leads coming out the bottom of the can, I hope, if I'm reading that correctly. And of course not. Let's see if I can show you. If you get vertigo here, I apologize. Here's the first IF can. We have a lead coming out here. We have another lead coming out here. Going over to this is the secondary of the first IF can. We have a lead coming out and going up here to the first. This is the primary of the first IF can. This is the secondary of the first IF cans. We have a lead coming up to there, which we should have, and one more lead, which is kind of mired down in here, and that goes over to pin 2, the plate of the 6A7, which makes sense. Oh, the grid cap of this, I made a mistake when I was reading the schematic. The grid cap of the, wrong schematic. The grid cap of the 6A7 is over here. It's not on pin 2. The plate isn't the grid cap, of course. The grid cap is one of the grids. So, okay, those are the 4 wires. We now know we'll have to make note of the orientation of the capacitor, and I'll just use that a permanent marker to mark a dot right here where these two go together on the chassis. Once we get the 4 wires unsoldered, there's a 1/4 inch nut right there that comes out, and that should drop the capacitor out the other side, or the transformer out the other side. So I'll get to work in removing and labeling these wires. After I take some reference photos. You know all about reference photos, right? I take a lot of them because I have a short little attention span, and I'll forget where the wires go if I don't do that. So I'm going to take some reference photos, and I'll get to desoldering, and we'll pull that out. Alright, this should be ready to come out. I've got all 4 leads unsoldered and free, so I should be able to remove that nut right there, or that bolt right there, and this first IF transformer should drop out the other side. He said, or pull up this way. It comes up this way. Well, son of a gun. Learn something new every day. Okay, I have to clear. Oh, rats. There's some leads in the way here. Oh, I have to desolder the grid cap right here. Of course. Hey. Okay. Now we'll see if we can get it out of here without causing it any more damage. And there it is. And it's wound on a wooden bobbin. It's a dowel. Put a couple of formers on there. This one they wound directly on the dowel, it looks like. Interesting. I don't know which lead is open yet. Now it I'm trying to see if it's been worked on before. It's possible. That solder there looks a little bit fresh, but it's hard to say. Everything else is wax covered, except for that guy. So that would be handy if that were just broken right there. But we don't even know if that's the one. Okay, that's next. All right, let's see what we can find out with this IF transformer. The part we want to look at is the connection, the lead that goes to the pin 2 of the 6A7 and the lead that goes over here to the primary of the second IF transformer. It's interesting. Yeah, so it goes there, it goes down here to this 39K. So let's see if I can figure if I marked that correctly. I might not have even marked that correctly. Let's find the one that goes to pin 2 of the 6A7. 6A7 pin 2 is right here. That's going up to, it looks like this winding up here. Yeah, I left enough wire to get connected to. And the other one appears to be here, the one I burnt up. So let's see if we get some continuity between these two. We shouldn't, that's for sure, but we'll see. And we do not. Okay, let's make sure that the other two are indeed the other winding. And they are. Oops. Yeah. So those two are the secondary and they're okay. This is the primary. And now we have to look and see. Boy, that is a very fine wire. Yeah, there's the wire right there. I have a microscope. I guess I'll get this under the microscope and see what we see. All right. Well, that's too bad. I think I haven't done anything. I think I know where the problem is. I also think I don't know how to fix it, or I'm incapable of fixing it, because it would require rewinding that, and I neither have the tools nor the inclination to do that. So I'm going to pull the one from the parts chassis and see if its continuity seems correct, seems appropriate, seems like it's working. That's what I'm trying to say. I'll pull that and get back to you. Here's the transformer out of the parts chassis. I haven't looked at this yet, so I think I did some preliminary measurements when I got that. Yeah, so Here's our, well, that's really bent. Looks like it's been bent for a long time. Guess it doesn't matter. So here's our primary up here, and these two leads are the ones we want to have continuity. And they do, thank goodness. So we've got 34.34 ohms, and the schematic calls for 34 on the primary side, 47 on the secondary. So let's check that real quick. And 44.45. So not 47, but 45. Okay, we have a good transformer. Breathe a sigh of relief. If anybody is up for rewinding one of these for themselves, I'm happy to pass this one along if you have a need. If you don't have a need, I'm not going to pass it along. Okay, I did decide to change the grid cap wire, mostly because I found I couldn't fish it. You have to fish it down into this tube and hit the hole where the grid cap wire comes out, and it was just too short to do that. Any easy way for me, so I just made a long wire here, and hopefully that will make the process easier. In theory. Ah, there it goes. Okay. I'll put this back in here and solder it up. We'll see if it works. Okay, we have the replacement first IF transformer in, and we're back where we can apply power to everything. So let's hook up the voltmeter to ground, and then to pin 2 of the 6A7 tube. And 2 is the one that doesn't get power if this transformer is out. If this transformer is open, no DC voltage gets to there. So what we're most interested in, we know we've got appropriate voltages all through here for the most part, and we know that we need 250 volts, give or take, right there. So we'll see if we can get that. I turned the variac down. I've got the speaker hooked up. Radio's on full volume. Put this meter on DC volts, and pin 2 is right there. Okay. Should be ready to rock and roll. We'll see. Okay, power on. We're still on dim bulb. Variac's all the way down, so I'm going to bring it up to about 50 volts. We should start to see some voltage develop right here almost immediately. Well, as soon as the there it comes. Okay, we're at 75 volts AC going into the radio. We're at, it's dropping because it's charging the filter caps. So down under 250, but we have voltage on the plate of the 6A7. That's what we needed. We needed that to be happening. And let's go ahead and run up to 100 volts. And now the speaker is starting to get a little speaker noise. And again, our plate voltage is dropping to 240 and we're looking for 250. I'd say that's pretty darn good. And we're getting some noise in the speaker. Okay, we can move on. I want to touch the grid caps of these tubes again, particularly the 6A7, and see if we can get any. Yeah. So we've got tubes powered and the circuitry working all the way from the RF input, right here where the grid cap is, through to the output, the speaker. Next comes the question of whether this little bit of coil right here is working or not. If this coil isn't attaching this switchable, on-offable, I guess is the way to put it, RC circuit right here. If that isn't going to ground, this is the antenna. You can hook an antenna to here. It isn't going to work very well. But let's see if we can get anything out of it by just putting my finger on the antenna and turning the tuning condenser. Nope. Okay, no surprise. What I will do is warm up the signal generator, and I'll inject a signal right here on the grid cap of the 6A7 and see if we can pick up some 460K intermediate frequency noise through here. That would tell us whether our transformers are all actually sort of tuned in, which would be cool. So I'll stop right here, we'll hook up the signal generator and go on from there. Let me show you the setup. Got my old leader signal generator with its fancy new digital display, set for 460 kilohertz. Internal modulation, I've got the output high but turned all the way down, going through a 0.047 microfarad capacitor to this end. I'm going to touch this end on the grid cap of the 6A7 and we'll see what we get. Okay, let me turn the radio volume down. Just going to reach under here and hold it on there. Actually, I could clip it on there if I could see it. Yeah. Clip it on right there. Okay. Let me move the microphone so you can hear what I'm hearing. And I'll turn the output of the signal generator up. All right, how cool is that? I'll move this now to the antenna input and we'll see if we pick up the same thing. I kind of doubt it, but maybe. This is the direct feed into the circuit from the 6A7. There, I'm off there. And I think yeah, this is the antenna input. Going straight into the antenna is a little bit. It's picking up a little bit. It's just barely there. Okay. So let me shut the signal generator down. Turn the radio off. We're 99% of the way there. 95% of the way there.
The makers of Johnson's Wagon.